Okay, now let's look at how your textbook has set it up. The textbook has set it up more like what we have here. It's a lot easier to do it in this fashion. So when you just simply straight run through acceptance. Okay, acceptance has like and dislike, and fat and salt are the two predictors. So if you run that and you run the plot, you see that you get one neuron for like and one neuron for dislike, and the net result will give you the two probabilities. Now your textbook does it in a slightly different way. So it sets up two columns, okay, called df like. So now that column is going to be set up as 0 or 1 based on whether it is like or not. So this will be like df acceptance equal to like. So that will be one column of 1 and 0, and then we have dislike so that would be dislike, or you can say not equal to. So let's do it this way. This will work, and so this is our not equal to, exclamation mark and equal sign. If it's not equal to like, then it'll be that. So let's run these two and see what new columns we get. Okay, so now if you look at df, then you get like true or false, okay, dislike true or false, right? So now we're going to use both of these in our neural network procedure. So let's run the neural network and save the results in NN. Neural net. Okay. Now you say like plus dislike. Okay, so those are the two columns we set up, and these two are our target, two different columns, and then we do salt plus fat. Okay, since there are other columns in there, we want to specify what the columns that need to be used as predictor, and then you say data equal to df, and then say hidden equal to, okay, let's use C2 comma 3. So that means there will be two hidden layers, first hidden layer with 2 neurons and second hidden layer with 3 neurons, and then we will set linear output equal to false. Okay, run that. Now if you plot this one, see here you have two hidden layers. Okay, first hidden layer with 2 neurons, second hidden layer with 3 neurons. Okay, now if you print the net results, you will see there are two probabilities. Okay, so now we can also, okay, we can use the predict function. So let's call that predict, pred to predict nn new data equal to df. Now you do that, and you get these two columns of predictions, which are the sigmoid function value, which are very close to probabilities. That's when you sum these two, you're not going to get 1 because those are close to probabilities but not quite. Okay, so and your the neural network also gives you one more function that can be used for probability, and so that would be, okay, so another, let's call it pred again, and that is called compute. Your textbook uses the compute command. So again, you give the neural net object, and then you have to provide a data frame of, when you use compute, you have to provide the exact predictors. So you have to say, specify it as a data frame, df salt, df fat. Yeah. So that will also give you the same thing. If you look at the pred column, now it gives you as a list. So now you have to peel the probabilities from net results. Okay, so net result will give you the probability there. Okay, there. Now let's look at, okay, we can also display the weights of the plot. Okay, so like if you say NN weights, so that will give you the weights, which we really don't we don't need this, okay, because we're going to be using those numbers implicitly. Okay, so let's look at how to come up with our predictions one more time. We previously used if else, right? So like right there. We can still use that. There is another way, and this is helpful when you have 3 classes like what we're going to see. Okay, so in that case you have to look at all the values, all the probability values, well, within quotes probability, because these are not exact probabilities but very close. So you have to look at these prediction values in each of the columns, and whichever is the maximum, we take that. And since if it is only 2 possibilities, then you can say whether it's 0.5 or not. Okay, now let's try to generate a confusion matrix again. So I'm going to copy paste this here, and let's change the hidden layer to just one hidden layer and 3 neurons. Okay, and then let us predict the probabilities. So we use pred. Okay, and NN net result, right? So that's going to have a probability, and we need this as a data frame. So let's put that into data frame. Okay, and that. So now we have pred. Okay, so we have those 2 columns. Okay, so now we're going to use apply to find the classes. Okay, so previously to determine the classes we used if else, right? So right here, if else probability is greater than 0.5, like or dislike, right? So we could do that also, and But when you have more than two probabilities, if you have three of them, or four of them, or five of them, then we have to look at which um, class has the highest probability. And that is the class that we will be specifying, classifying the observation as. So we have to look at all of those different probabilities and see which is maximum, and that you cannot do with if else. So that's the reason why we will use apply. So we'll rename this to probability, right? So we'll run that and see that's our probability. Okay, and then our prediction is going to be, and we're going to do the apply. Apply has three parameters. The first is uh, the data column, so here which is prob, right? And then whether the apply should be applied column wise or row wise. Column wise means margin is 1, row wise is 2. We need 1 is row wise, 2 is column wise. We need row wise because each row we have to look at the probabilities and see which one is maximum. So now what we want is, we really don't want the value of the maximum probability. What we want is in which position that maximum occurs. Is the maximum the first value, or is the maximum second value, or the maximum third value, and so on. And that we get with which max. So which max will go through by column wise and see which one of those is maximum. So when you run that, okay, so now let's look at spread. So here are the classifications, but you see the classifications are 1 and 2, not 0 and 1. See, our classification should be either 1 for like and 0 for dislike. But this appears in 1 and 2 because the probabilities for 0 is in column 1 and probability for 1, which is like, is in column 2. So therefore we need to subtract 1 from here. Then we will get the predictions correctly. So now if you look at predict, so the first one is predicted as 0, then 1 1 1 and 0. All right, so now we can run the confusion matrix. Okay,